New photos of 3I Atlas may have just upended everything we thought we knew about comets. For months, this interstellar object, making its way through our solar system, was widely believed to be just another typical comet, a cosmic traveler with a familiar tail of gas and dust. But the latest images suggest something far stranger. This new data might indicate that it's something far more mysterious, perhaps even something that could force a complete rethinking of our understanding of the universe. When 3I Atlas was first discovered in July 2025, astronomers were initially thrilled by its interstellar origin. Here was an object not bound to our solar system, but instead passing through it on a fleeting visit. For a time, the scientific community assumed this would be just another icy object, like the famous comets that we have observed over the centuries, like Halley's Comet, or the more recent Oumuamua, which itself was a visitor from outside the solar system. 3I Atlas appeared to be following a similar trajectory, and the consensus was that it was a comet. But as the object grew brighter and more images were captured, the reality began to shift, and what was assumed to be a simple comet slowly revealed itself as something much more peculiar. In the earliest images, 3I Atlas seemed to fit the comet template. It had the classic look of a comet, a faint fuzzy coma, and a tail that stretched out behind it as it approached the sun. But as astronomers started to capture more detailed photos and data, the behavior of the object began to defy expectations. Instead of the traditional tail, pointing away from the sun, as is typical for comets, 3I Atlas exhibited an anti-tail, a tail that appeared to point directly toward the sun. This behavior was unprecedented. For centuries, astronomers have observed comets' tails as they stretch out behind the nucleus, following the solar wind and radiation pressure. Yet 3I Atlas's anti-tail pointed in the opposite direction, toward the sun, defying all conventional wisdom about comet behavior. This discovery raised immediate questions. Could this be a mistake in the observation? Could it simply be an optical illusion or a result of the object's unique position relative to Earth? These possibilities were quickly ruled out when subsequent images continued to show the anti-tail in a consistent pattern. The anti-tail was not a fleeting anomaly. It was a persistent feature of 3I Atlas, present in several observations taken over time. The confirmation that 3I Atlas had this anti-tail prompted the scientific community to pause and reconsider. Was this really a comet, or was something else at play? In typical comets, the tail is created by the interaction of the object's outgassing, the release of gas and dust particles, into the solar wind. As the comet approaches the sun, the heat causes it to sublimate, releasing material that is swept away from the nucleus by the solar wind, creating the classic tail that points away from the sun. However, 3I Atlas didn't follow this pattern. Instead of the expected tail, it was emitting a strange anti-tail, one that pointed in the opposite direction, toward the sun. This was the first major clue that 3I Atlas might not be a comet after all. So, what was causing this anti-tail? One possibility that was initially considered was that the object was expelling unusually large dust particles. Large dust particles would be less affected by the solar wind than smaller particles and could potentially form a different kind of tail. If this were the case, the anti-tail might be the result of larger particles being released from 3I Atlas's nucleus, and the solar wind might not have enough force to push them away from the sun. However, this theory doesn't fully explain the absence of a conventional dust tail. If the object were emitting large particles, we would expect to see at least some kind of dust tail, even if it were faint. But no such tail was visible. The only feature observed was the anti-tail, which seemed to defy all expectations. The lack of a conventional tail and the presence of the anti-tail raised another major concern. If the object were indeed emitting large particles, they should still be affected by solar radiation pressure to some extent. While larger particles might resist the solar wind more than smaller ones, they would still experience some push from solar radiation. However, 3I Atlas's anti-tail wasn't behaving like any cometary tail ever observed. It appeared to be unaffected by the forces that typically govern comet behavior. This added to the growing mystery surrounding the object's true nature. As astronomers delved deeper into the new images of 3I Atlas, they began to uncover a series of anomalies that further set it apart from any known comet. One of the most startling discoveries was the object's unusually fast rate of rotation, approximately 3 full rotations per day. In typical comets, the rate of rotation plays a critical role in shaping how the material is released from the nucleus. As the comet spins, the centrifugal forces cause jets of gas and dust to be ejected from the nucleus. These jets are typically spread out, fanning in a predictable pattern due to the rotation, which helps to form the comet's tail. The faster the rotation, the more pronounced this fanning effect becomes, and it is a feature that astronomers expect to see in most comets. However, 3I Atlas did not follow this pattern. Despite its rapid rotation, the jets coming off the nucleus did not exhibit the characteristic fanning behavior. Instead, they remained fixed in a straight line, pointing in the same direction without the typical spread caused by rotation. This unexpected behavior raised immediate questions. Why weren't the jets fanning out? What was causing them to remain so tightly focused, unaffected by the object's spin? The lack of the usual fanning effect was a clear indication that 3I Atlas was behaving in a way that was entirely unlike any comet ever observed. This unusual jet behavior prompted some astronomers to speculate that the jets might be originating from fixed points on the object's surface, specifically near its poles, rather than from the equator as we would normally expect in a rotating comet. In typical cometary jets, material is ejected from the equator, where the centrifugal forces caused by the object's rotation are strongest. This results in the fan-like spread of the jets as the object spins. However, if the jets were coming from fixed points near the poles, they wouldn't be influenced by the object's rotation in the same way. The material would be ejected from the poles, and the rotation would have little effect on the direction of the jets. This could explain why the jets appeared to remain fixed in place, pointing consistently in the same direction without any noticeable change despite the object's rapid spin. The idea that 3I Atlas's jets might be emanating from the poles also opens up further questions about the object's internal structure. If the jets are indeed coming from fixed points near the poles, it suggests that the internal dynamics of 3I Atlas are vastly different from those of typical comets. Most comets have a relatively uniform structure, with their jets emerging from the central region of the nucleus, influenced by the rotation of the object. However, if the jets of 3I Atlas are coming from the poles, it could mean that the object has an unusual internal configuration, one that doesn't rely on the standard forces we expect to shape cometary behavior. Moreover, the lack of a fanning effect raises another intriguing possibility. Could 3I Atlas be rotating differently from other comets? Perhaps its rotation is not as uniform or smooth as that of other comets. If 3I Atlas is rotating at such a high speed, yet still showing no significant fanning of its jets, it could suggest that the internal structure or composition of the object is playing a significant role in how the material is being expelled. There might be some sort of internal force or mechanism that controls the direction and spread of the jets, overriding the usual effects of rotation. This would indicate that 3I Atlas is far more complex than simply a comet made of ice and dust. If the jets are indeed emanating from fixed points near the poles, it could also suggest that 3I Atlas is not composed of the same materials as other comets. The traditional understanding of comets is that they are made up of a mixture of ice, dust, and gas, which sublimates as the object approaches the sun. This sublimation leads to the formation of a coma and tail. However, if 3I Atlas has jets coming from the poles, it might indicate that the object's composition is fundamentally different from that of typical comets. It could be that 3I Atlas contains materials that are not as easily sublimated by the heat of the sun, or that its structure is more solid and less prone to the typical outgassing process that characterizes other comets. All these anomalies, the fast rotation, the fixed jets, and the lack of the usual cometary fanning effect, point to a possibility that cannot be easily dismissed. 3I Atlas may not be a comet in the traditional sense at all. Its behavior challenges the basic principles of cometary dynamics, suggesting that it is something far more complex and potentially far more mysterious than a simple icy object from the outer reaches of our solar system. Could 3I Atlas be something entirely new, something that forces us to rethink our understanding of comets and other interstellar objects? If the jets are indeed coming from fixed points near the poles, it raises the stakes of this mystery even higher, as it implies that 3I Atlas has an internal structure unlike anything we've ever encountered. The behavior of the jets and the absence of a conventional tail were not the only puzzles presented by 3I Atlas. After the object passed perihelion, the closest point in its orbit to the Sun, it continued to exhibit strange behavior. Normally, when a comet passes perihelion, its orientation changes due to the forces acting on its nucleus. The solar wind and radiation pressure from the Sun typically cause the rotational axis of the object to shift, affecting the direction of the jets and tail. However, 3I Atlas defied this expectation. Despite passing perihelion, its orientation remained remarkably stable. The jets continued to emit from the same direction without any noticeable shift. This is highly unusual, as even the most stable comets tend to experience changes in orientation after passing perihelion. The fact that 3I Atlas maintains such consistency further challenged the idea that it was a typical comet. Could 3I Atlas be something else entirely? Some scientists have speculated that the object may not be a comet at all, but rather an artificial object, a probe or spacecraft sent from another star system. While this theory remains highly speculative, the strange behavior of 3I Atlas has made astronomers rethink what they know about interstellar objects. The object's resistance to solar wind, its anti-tail, and its unusual jet behavior all point to something beyond the typical understanding of cometary science. Could 3I Atlas be an artificial probe sent to explore our solar system? It's an intriguing idea, though still far from proven. There is another possibility. 3I Atlas could be a completely new type of object, one that we have never encountered before. Its strange features might point to a new class of interstellar body, one that challenges everything we thought we knew about celestial mechanics. The object's behavior could indicate that there are objects in our galaxy that we have yet to categorize, and 3I Atlas might be the first of its kind to be observed in such detail. In conclusion, the discovery of 3I Atlas has forced scientists to reconsider the basic definitions of what a comet is. The presence of an anti-tail, the lack of interaction with solar wind, the behavior of the jets, and the strange rotational dynamics all point to an object that doesn't fit the typical cometary mold. Whether it's a comet, an artificial probe, or something entirely unknown, 3I Atlas is a reminder that there is still so much about the universe that we don't fully understand. The object's resistance to solar wind, its anti-tail, and its unusual jet behavior all point to something beyond the typical understanding of cometary science. Could 3I Atlas be an artificial probe sent to explore our solar system? It's an intriguing idea, though still far from proven.